This is our dynamics for AP Physics 1 video number 5, and we're going to start with this question. It states an object with a mass of m1 5 kg rests on a frictionless horizontal table and is connected to a cable that passes over a pulley and is fastened to a hanging object with a mass m2 10 kg as shown. Find the acceleration of each object and the tension in the cable. What distance do they both travel if they were released from rest and for 0.2 seconds? So the distance they travel over 0.2 seconds. So at first we're going to do the free body diagram and write all the forces acting on the objects. So I'm going to start with the one on the horizontal surface. It's frictionless, so I don't have to worry about the friction, but there is a normal force. There is the force of gravity, m1g, and there is a tension force. And the tension force is the same one because it's the same rope, so the tension causes the same in both of them. And the second one also has tension and m2g. And there is acceleration. So when they say free body diagram, again, they only put the forces acting on the object, not the acceleration. After you're done with the free body diagram, you can do on your own on AP exam. On the side somewhere, you can redraw the whole graph and put the acceleration. But never do this in the graph where they ask you to put the free body diagram for forces and write the forces acting on the object. So every time after I finish my free body diagram, I'm going to write the second Newton's law for each body. So the net force is equal to A. Let me put acceleration first before I forget it. So acceleration is going to be this way, and acceleration is going to be this way. So the free body diagram, I have the system of two equations. One is going to be for mass 1, and one is going to be for mass 2. The vertical forces on the mass 1, the normal and m1g, cancel each other, and because I don't need the normal force for my friction, I don't even have to write that equation. What I'm going to do is tension is equal to m1a. That's all the forces, so the net force is tension, and it causes acceleration m1a. For the second mass, I have tension in the upper direction and m2g in the down direction. And that is equal to negative m2a. So it's the sum of the forces equal to ma. So because I know what the tension is, so this is my tension, I can plug it in instead of tension. So then I have m1a minus m2g is equal to negative m2a. So the acceleration is equal to m2g divided by m1 plus m2, and that is equal to 6.6 meters per second squared. Now, if I take this acceleration and plug it in into any of the two formulas that I have at the beginning, I will get that the tension is equal to 33 newtons. And if I have to find the distance it traveled over the 0.2 seconds, I need initial velocity is 0. I need the final velocity. The final velocity is equal to initial plus acceleration times the time. So the final velocity is equal to 0 plus acceleration times the time, which is 0.2 seconds. So the final velocity is equal to 1.32 meters per second. So now if I'm looking for the distance to travel over 0.2 seconds, I have the distance is average velocity times the time. Average velocity is 0 plus 132 divided by 2 times 0.2 seconds gives me 13.2 centimeters, not meters, centimeters. Here's one more question I want to look with you at. A rope of negligible mass passes over a pulley of negligible mass attached to the ceiling as shown in the figure. One end of the rope is held by student A of mass 90 kg, who is at rest on the floor, and the opposite end of the rope is held by student B of the mass 70 kg, who is suspended at rest above the floor. Calculate the magnitude of the force exerted by the floor on student A. and student B is now climbing up the rope at the constant acceleration of 0.2 meters per second squared with respect to the floor. So the student B is climbing up and the student A is holding down to the floor. The question is by how much, what is the normal force on the student A from the ground? And as always, I'm going to start with a free body diagram. My student B is going to have mass 2, so this is M2G, and the tension in the rope is up. My student A is going to have also tension, so there's tension, and M1G. And there's something else in student A. There is a normal force as well. So there is a tension and there is a normal force on the student A as well, because the student A is standing on the ground. And also there is acceleration for the student B. In the free body diagram, you don't write acceleration. I just keep repeating it, so it just will be engraved in your memory. So in the free body diagram, you don't place acceleration. Now, after I have my free body diagram, I'm going to write the equations. So the student A has tension pointing up, normal force is pointing up, M1G is pointing down, and student A is not accelerating, it's standing on the floor, so the acceleration is 0. For the student B, I have the tension is up, M2G is down, and this, the second one, the B object or student has acceleration up, so that's M2A. Now, if I solve for the tension, the first equation, I get M1G minus the normal force. So that is for the first student, A, and for the second one, I can plug in all this instead of the tension. So now, if I plug it in, I have M1G minus the normal force minus M2G is equal to M2A. And I am solving for the normal force. So the normal force is equal to, I can take G out, and what's left is M1 minus M2. I moved N to the right, and I have to subtract M2A from the right to the left, minus M2A. So my answer is going to be 186 newtons. So if the student A was standing on the ground without holding the rope, the student A has a mass of 90 kilogram from our statement. So the force of gravity would be 900, and the normal force would be 900. But because the other student is pulling up, the normal force becomes 186 newtons instead of 900. Here's one more question that I want to solve with you together. So you have two masses. One is 100 kilogram, the other one is 300 kilogram. Again, we're going to start with the normal forces. They ask you to find acceleration and the tension in the rope. So we have, and it is frictionless horizontal surface, so you don't have to worry about the friction. So the force up is normal force, and this one I'm going to call it M1 G. And then I have tension. And because you see the rope bends and then goes around, and at point C goes up again, it's all the same rope. So I can call this tension, and the other one is tension as well. So it looks like there's two tensions pulling the block 300 kilogram up, and only one tension is pulling 100 kilogram block down. And then also the 300 kilogram block has M2G acting on it, the force of gravity. I also want to place my accelerations here. So for the first one, I'm going to say this is my acceleration, and this will be acceleration as well. But how is the second acceleration related to the first one? let's look at this. If an object on the top travels this distance, an object on the bottom travels 1/2 of this distance. So if this is the distance, this is 1/2 of the distance because the rope is bent at point C. So over the same time, so let's say they both started with 0 meters per second, 0 meters per second, 0 meters per second. And then final velocity is going to be, so the final velocity, well, let's say average velocity so you understand it better. So the average velocity in this path D is going to be the distance over the time. And average velocity is initial plus the final divided by 2. And then for the second one, you have initial velocity, the average velocity in this case, so that was average velocity, and the average velocity in this case, in the second one, is 1/2 the distance over the same time. It travels 1/2 of the distance, so its initial velocity plus this was final velocity of the first one, this is final velocity of the second one, divided by the by 2. So do you see that the final velocity of the second one is going to be half of the velocity of the first one? And if over the same time the second one has over only 1/2 of the velocity of the first one has twice the acceleration of the second one. So the second acceleration is equal to 1/2 of the acceleration of the block that is moving horizontally, because it doesn't reach the same velocity, it only reaches the same half of the velocity that the top one does over the same time. Okay, so now when we have our free body diagram, I can write second Newton's law. So for the mass on the top, again, there's no friction, I don't have to worry about the normal force. What I only have there is tension is equal to M1A. And for the bottom one, I have two tensions pointing up, minus M2G is equal to negative 1/2 M2A. And I see what the tension is equal to, so I can right away use my tension and plug it in instead of the tension. And also, I want to multiply the second equation, the whole equation, by 2. So I'm going to multiply 1, 2, 3 terms by 2 to get rid of the fraction. So I have 4. Instead of the tension, I can plug in M1A. Then I have minus, I multiply it by 2 because I multiply every single one of them by 2, M2G, and equals to negative. And if I multiply by 2, 1/2 goes away, and I have M2A. So now I can move M2A to the left side and M2G to the other side, and so for acceleration, so acceleration is going to be equal to 2M2G divided by 4M1 plus M2, and that is equal to 8.57 meters per second squared. And if I plug it in into my tension formula, I get the tension is equal to 857 newtons. So here's one more question. The lower block in the figure is pulled by a rope with a tension of 20 newtons. The coefficient of kinetic friction between the lower block and the surface is 0.3, and the coefficient of the friction between the lower block and the upper block is also 0.3, which makes it easier. What is the acceleration of the 2 kilogram block? And I had to check why it wouldn't show which one is 2 kilogram, which one is 1 kilogram. So the top one is 1 kilogram block, and the bottom one is 2 kilogram block. So as always, I'm gonna start with the forces acting on the blocks. So I'm gonna do the top one as a dot, so it's easier gonna be with the forces that are acting on the block, and write the forces acting on the block. So I have M1G. M1 is 20 kilogram, and then also the force acting, pulling it with 20 newtons. So I have M1G, and then the normal force, I'm gonna call it normal 1, Then I have the tension force this way, and there is a friction force that way, and I'm going to call this one friction 1. Well, let's call it little f. So this is friction 1. So this is for the top one. For the bottom one, I have M2G. I have the normal force 2. Then I have the force with which it's being pulled, F. So this is the force F. And then I have the tension. And then I also have a friction 1. So that is the friction 1 from the top, between the top and the second one, because the top one is moving to the left and the bottom one is moving to the right. So there is the friction as well. So now I have, and there will be acceleration. So this one is moving this way with some acceleration, and the bottom one is moving this way with some acceleration. Now let's write the F net is equal to ma. For the top one, I have acceleration is my positive direction. I, like 99% of the time, I'm going to choose acceleration in my positive direction. So the tension goes with acceleration. Tension is positive. Friction in the opposite direction, and equals to m1a. And for the bottom one, again, acceleration is my positive direction. So the force is a positive direction, but the friction 1 is negative. The tension is negative, and I need friction 2. I also need friction 2. I forgot about friction 2. So there is another force. Maybe let me do it this way. I'm gonna make this as friction 2, and then there is the tension force as well. So I have minus the tension minus the friction 2, and so that is all horizontal forces, and equals to m2a. And let's write this force as well, because downward on m2 you have the force acting from m1. So let's write this force is n1 is acting on it, on the second one, because the top one is the top one is on the bottom, so there is additional normal force acting on it. So n1. So for vertical forces, that will determine my, so N1 and M1G will determine what my friction is equal to, F1 and F2. F1 and F2 will depend on the normal forces. So in your friction is equal to mu times normal force. And I need to determine that part. So here I'm going to solve for tension. Tension is equal to M1A plus the friction force. And the friction is mu. They have the same coefficient of friction. And M1G, because the normal force is equal to M1G for the first block. So I'm going to solve this one for tension. I'm going to solve the other one for tension as well, so it's easier on me. Just set them equal up to each other later. The tension for the second one, so I move the tension to the right and M1A to the left. So I have equals to force minus M2A, because I move my M2A to the left and tension to the right, minus F1, so minus mu M1G, and minus friction 2, and the friction 2 is mu, but the normal force is going to be the addition of the other ones, two of the masses. So that is M1 plus M2G. Now I'm going to set them equal to each other. So I set them equal to each other. I also distributed them. So I see there is M1G and M1G. So there's M1G and M1G. I'm going to combine them together. And how come you didn't tell me, guys? I wrote M2AG, M2G, but it's M2A, right? Because I have M2A. So this is M2A. I subtracted M2A from both sides. So it is M2A. Okay, now I have it fixed. I'm going to move my A's all on one side. and solve for acceleration. So I also noticed when I was combining all like terms, I noticed that this, and this together will give me negative 3 m1g, mu m1g, and then I have negative m2, mu m2g, and that's it. Now I can solve for acceleration and plug in my numbers. And I get 167 meters per second squared. Here's one of the questions I want to mention in this video, and I haven't seen many questions like this related to AP Physics 1, but I want you to understand how it works. So it's the same rope again, and because it's the same rope, you have tension right here, you have tension right here, and you have the same tension right here. And the force of gravity right here is 100 newtons. So because they say it is balanced, that means acceleration is equal to 0, so the objects are not accelerating. Doesn't mean they're not moving at a constant speed. They might be moving at a constant speed, they're just not accelerating because the forces are balanced. So they say the forces are just balanced. And because there is no acceleration, I know that two tensions that are pulling a 10 kilogram block, so these two tensions that are pulling 10 kilogram block, they together must give you 100 newtons. So I know that 2 T's equal to 100 newtons because there's no acceleration, they're equal to each other. Then 1 T is equal to 50 newtons. If 1 T is equal to 50 newtons, then this one is equal to 50 newtons. Then the one that is acting down must also be 50 newtons. So the mass is 5 kilogram. Here's another question I want to look at with. A mass M is held in place by the applied force F. So the force is equal to in place. So that means the force down is equal to the tension force. So they are equal to each other. So this tension, because again, it's the same rope. I have two tensions here. I'm not going to call it T1, T2, T3, but there's two tensions. And this one is mg. So I know that two tensions is equal to mg. So one tension is equal to 1/2 mg. That means the force that is pulling down is equal to 1/2 mg. So I hope to fit one more question into our lesson in this video, and we're going to be done with this video. A woman at an airport is towing her 20 kilogram suitcase at a constant speed by pulling on a strap at an angle above the horizontal. She pulls on the strap with a force of magnitude 35 newtons, and the frictional force on the suitcase is 20 newtons. Draw the free body diagram for the suitcase, and what angle does she hold her, applies the force, what normal force does the floor exert on the suitcase, and what is the coefficient of friction between the suitcase and the floor. So I know it's constant speed. So I know it is a constant speed. The mass of the suitcase is 20 kilograms. She is pulling at the magnitude of 35 newtons, so she applies the force right here, 35 newtons. I'm going to call this force F. So let's draw the free body diagram. So I have a suitcase. The forces acting on it are mg. The mass is 20 kilograms. The normal force, the force that the lady is pulling with, I'm going to call it tension, and the friction force, and I'm going to call it the lowercase f, friction force. Then a constant speed, so there's no acceleration. I can say that acceleration is equal to 0. You don't put this on your free body diagram. So for the free body diagram, I can say the net force is equal to ma. So the net force horizontally, I need to do my, let me erase acceleration. I need to do my horizontal and vertical component for tension because it doesn't align with the horizontal vertical axis. And here is an angle. So I have T cosine and T sine. So this cosine theta and T sine theta. So horizontally, I have T cosine theta, I'm going to choose positive, minus the friction is equal to 0. There's no acceleration. Vertically, I have the normal force plus T sine theta and equals to minus mg is equal to 0, but I'm going to say equals to mg. Or let's do it the right way. Minus mg theta minus mg equals to 0. So I have it this way, system of two equations. Now, from this equation, because they give me the friction, I can figure out what angle is equal to. Angle is equal to arc cosine, the inverse function of cosine, and it is f over t. It's f over t, and they give me tension is 35 newtons. So from here, I see that the angle is equal to 55.15 degrees. So that is one of the questions answered, the angle. What's the normal force that the floor exerts on the suitcase? The normal force is equal to mg minus t sine theta from the second equation. So I have the normal force is equal to 171.27 newtons. And the last part in this question, the friction force. So the friction force is equal to mu times m. I know my friction, they give me 35 newtons. It's given in the problem, correct? So right there, 35 newtons. And mu I'm looking for, and the normal force is 171.27. So mu is equal to 35 divided by 171. And that one is 0.2. So that is my coefficient of friction.